So first
Huh.
topic in Kirchhoff laws is basically junction. So junction means meeting point. Junction is defined as meeting point
Meeting point.
of
Huh.
two or more than two wires. Two or more than
Two.
two wires. So these are called as junctions. I repeat,
Yes.
junction means meeting point of two or more than two wires. So
Huh.
suppose this point is called as junction. So if you consider this as junction, the junction is basically
Huh.
the meeting point of two or more than two wires. So these are the
Yes.
wires. So let us assume
Huh.
the incoming current to be I1. So this is outgoing current I2. We have I3. This is I4. I2. So this point is called as junction.
Junction.
This point is called as junction. This
Yes.
junction. This I1 current, I1, I3, they are called as
Huh.
incoming current. Why they are coming towards the junction? So I1 and
Yes.
I3 they are called as I1, I3. They are called as incoming
Incoming
current.
current.
Incoming current.
Sir,
While
I1
while
or I2
I2
be?
while I2 and I4 they are moving
Huh.
away from the junction. They are called as outgoing current. I2 and
Huh.
R4 moving away from the junction. They are called as outgoing current. Outgoing current. So incoming currents are those current which are coming towards the junction, while
Huh.
outgoing currents are those current, which are moving away from the junction, which are moving
Yes.
away from the
Away from
junction.
the
Now it is
junction.
important to note that incoming
Huh.
currents they are always considered as positive, while outgoing current they are taken as negative. I
Negative.
repeat, incoming current they are treated as positive. So incoming currents
Positive.
are treated as positive.
Positive
Outgoing
current.
current they are taken as negative. So I3 is
Negative.
negative, I4 is negative. I4 is negative.
Huh.
I3 and I4 both are
Yes, sir.
negative. Now, first law. There are two laws of Kirchhoff. So first
Huh.
one is called as Kirchhoff junction rule. Now write in the next
Yes.
that is called as Kirchhoff
Kirchhoff
junction law.
junction
Kirchhoff
rule. Huh.
junction rule. Yeah, Kirchhoff's law of current.
Yes, sir.
Kirchhoff's law of current. Kirchhoff law of current.
Huh.
It is also called as KCL. KCL. This law is also called as KCL. Now,
KCL.
this law states that summation of incoming current is always equal to summation of outgoing current. So,
Yes, sir.
this law states that sum of sum of incoming current is always equal to sum of incoming current is always equals to sum of outgoing current is always equal to
Yes.
sum of
Outgoing
outgoing current.
current.
Outgoing current.
Huh.
So summation of incoming current is always equal to summation of outgoing current.
Outgoing current. Yes.
Formula. Formula. Summation of incoming current. Incoming current is always equal to summation of outgoing
Outgoing current.
current. Incoming current is always equal to summation of outgoing current. Now it is
Huh.
important to note that the current that is coming toward the junction that we already discussed, those current are
Yes.
called as incoming current. So
Incoming current.
I1 is basically incoming current, I2 is also
Huh.
incoming current, I
Yes.
is outgoing current, I4 is incoming, I5 is
I5
outgoing.
outgoing.
Now summation of incoming current is always equal to summation of outgoing current. So what we do,
Yes.
we just apply this sign convention and we add the current. So I1 is
Huh.
taken as positive, I2 is also taken as positive incoming,
I
and we have incoming out I3. I3 is taken as negative,
negative.
I3 is negative, I4 is taken as positive,
Positive.
I5 is taken
I5
as negative
negative.
equal to 0.
Huh.
So we can write this expression as I1 plus I2 plus I4, I1 plus I2
Plus
plus
I2 plus
I4
I4
is equal to
is equal to
I3 plus I5. I3 plus I5. I5. So I1 plus I2 plus I3, this is called as incoming current. And I2
Yes, sir.
plus I5, that is, this is nothing but outgoing
Outgoing.
current. Outgoing current. So this law satisfies conservation of charge. So it is important to note that KCL is
Con-
based on conservation of charge.
Conservation of charge. Yes, sir.
Conservation of charge.
Huh.
Conservation of charge. So incoming current is always equal to outgoing current. Hope
Yes.
concept is clear.
Yes, sir.
Now next article. Next article
Sir,
is called as
ये
KVL,
मैंने note नहीं
Kirchhoff
किया ये.
voltage law. KVL, that is called as Kirchhoff voltage.
हाँ.
Kirchhoff voltage law. Now KVL law states that, so Kirchhoff voltage law states that the algebraic sum of potential difference of all components and source of EMF is equal to 0. I repeat, summation of potential difference due to component. That means we are talking about potential of difference due to resistance. Due
Yes.
to resistance. This is potential difference. Potential difference due to resistance plus
हाँ.
summation of EMF, electromotive force due to battery, is always constant. Is always constant. I repeat, summation of potential difference due to resistance and EMF due to battery is always constant. So this is nothing but Kirchhoff voltage law. I repeat, Kirchhoff voltage law states that algebraic sum of potential difference of all component and source of EMF is always equal to 0. That means summation of IR plus summation of EMF is equal to constant. Now it is
Yes.
important to note that KVL, Kirchhoff voltage law, is also called as mesh law. It is also called as mesh law. Mesh law or loop law. Loop law, mesh law or loop law. It is based on conservation of energy. This law is based on conservation of energy. This law is based on
Yes.
conservation of energy.
Energy.
Conservation of energy. I repeat, KCL is based on conservation of charge and Kirchhoff voltage law is based on conservation of energy. Conservation of
Energy. Yes.
energy. Now, an example to demonstrate KVL. An example to demonstrate KVL. So what we do, we just draw a circuit. We'll draw a circuit.
Yes, sir.
We draw a circuit like this. Yeah. So this is a complex circuit basically. It consists of resistance, yeah. So this is basically a complex circuit. So complex circuit
Yes.
consists of resistance and
हाँ.
combination of battery. So suppose
हाँ.
we have battery. Let us name the battery as given. Resistance as R1. This is resistance R2. We have resistance R3. This is R4. We have resistance R5. This is R6. R7 resistance. This is R8 resistance. And we have battery, that is E2. Battery.
E2. हाँ.
Now let us name the points. So we have point say A. So this is point A. We have B. This is point C. This is point D. We have E. And this is point E and F.
E.
So this is point
Yes,
E.
sir.
This is point F. So we have D. Then we have E. And we have point F. Clear? Now it is
हाँ.
important to note that. So basically, this is a complex circuit. Any circuit
हाँ.
that comprises of resistance and more than two batteries or more than two batteries, so it is called as
हाँ.
complex circuit. Now, in order to solve complex circuit, Kirchhoff has given two laws. That is Kirchhoff first rule, that is called as KCL, and we have second law that is called as KVL.
हाँ.
Now, I will tell you how to apply this law while finding the values, different values. You can find the potential difference. You can find the current. You can find
हाँ.
anything. So what we do generally, Step number one. Step number one. So we have several steps. So
Yes.
step number one. Step one. Mark current in each resistance. I repeat. Step one. Mark current in each resistance. Each
Mark
resistance. Mark
current in
current
each
in each
resistance.
resistance. So
Yes.
suppose we have a current. So let us assume this is battery E1. So the current that is passing from E1 is say I1. So I1 is the
Yes.
amount of current that is passing through the resistance R1. R.
Huh.
So we have current I1 across R3. After reaching this point, current
Huh.
I1 will take a shortcut. So this is current I1 and the circuit is complete. Similarly, the current that is passing from battery E2 is I2. So this is I2. So I2 is passing through R7. Similarly, I2 is passing through R6. And in R4, we have combination of I1 and I2. Similarly, in
Yes.
R5, we have combination of I1 and I2.
R1 and
Circuit is
R2.
complete. So step number
Huh.
one, mark the current in each resistance. Step number
Yes.
step number two. Step number
Huh.
find a number of loops. Find number of loops. Find a number of loops.
Find number of
A
two.
loop
Huh.
is a closed path which has a resistance and minimum at least one battery, or we can have two
Yes.
batteries, right? But minimum it
Huh.
should have one battery. So there are three loops in it. So first loop
Yes.
is basically loop A, B, E, F, A. So first loop A, B, E,
B.
F,
E.
A. So this is first.
Huh.
Second loop is B, C, D, E, B. Loop
Yes.
loop B, C, D, E, B. And the third loop,
Huh.
third loop, third loop is basically the bigger one. So A,
A,
B, C, D,
B,
E,
C,
F, A.
D, E.
A, B, C, D, E, F, A. A,
Yes.
B, C, D, E, F, A. So this is the
Huh.
outer loop, basically, bigger one.
Huh.
Now, what we do, we need to solve this loop, basically. So we'll solve loop, first loop, first loop. We'll try to solve first loop.
Yes, sir.
So step number three. Step number three. If direction of current and the loop
Huh.
is same, I into R is negative. I repeat,
Yes.
if the direction of current and direction of loop is same, product of
Huh.
I into R is negative.
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 Huh.
Second rule. Second rule. If you are moving and you receive the negative terminal of battery first, then EMF is positive. Then EMF is positive.
Positive.
These are the two
Yes.
tricks basically that we have to remember. Now we
Huh.
try to find loop A B E F A. Loop A B E F A.
Huh.
Loop A B E F A. Now see loop A B E F A. Now current is passing from A to B, A to B, A to B.
Huh.
So if
Yes, sir.
direction of current and the loop direction is same, I into R is negative. So minus I1 R3.
Huh.
Minus I1 R3.
Fine.
Now
Huh.
from B to E, B to B to
B to E.
E. So we are moving in this direction. Current is also moving in the same direction. I into R is
Huh.
negative. So minus I1
Um,
plus I2 times R3
Huh.
minus I1 plus I2 times R5.
Huh.
So we are right now at this position E. Now from E to F, we have no battery, no resistance, zero.
Yes.
Now from F to A, we are moving from F to A, F to A. While moving from F to A, if you observe, we are getting the negative terminal first. That means EMF is taken as positive. If you receive negative terminal first, if you encounter
Huh.
negative terminal first, EMF is positive. So it is plus times of E1 plus E1. Then when you move forward, we have minus I1 R1 minus I1 R2 equal to 0. Equal to 0. So this is how we generally solve loop. Now second loop, I will show you the next loop also. This
हाँ
one.
yes.
So suppose if I want to find the loop, bigger loop, I will solve the bigger loop first. Bigger loop.
हाँ
So A, B, C, D, E, F, A. Loop. A, B, C, D, E, F, A. So if I'm solving loop, the bigger loop, so see,
हाँ
I'm moving from A to B. The direction of current and the direction of loop is same. So I into R is negative. So minus I1 times R3. Similarly, it is plus I2 R6 plus
yes.
I2 R6. Then we are moving from C to D. So from left to right, and the current is moving from right to left. So it is minus I2 R7 minus
हाँ
I R7 minus I2 R8. Then you are getting the battery ka bigger terminal first. So if we are
हाँ
getting battery bigger terminals first, so E2 is negative basically. E2 is
हाँ
negative. So minus E2
हाँ
minus E2. So right now we are at position D. From D to E, no battery, no resistance, zero. E to F, no battery, no resistance, zero. Now from F to A,
हाँ
so it is positive E1 plus E1, positive E1 plus E1. Now current direction resistance same, so it is minus I1 R1 minus I1 R1 minus I1 R2 equal to 0. Minus I1 R2 equal to 0. So this is a basic loop. This is a I
हाँ
hope the concept is clear.
हाँ सर स्टेप नंबर 3 एक बार समझाना.
स्टेप नंबर 3, अगर करंट का डायरेक्शन लूप का डायरेक्शन सेम है तो आई इंटू आर नेगेटिव होता है. जैसे यहाँ पर देखो,
हाँ
अगर मैं ऊपर जा रहा हूँ ऐसे, अगर मैं ए से बी तक जा रहा हूँ और करंट का भी डायरेक्शन सेम है, मेरे साथ साथ करंट जा रहा है, तो आई इंटू आर
हाँ
नेगेटिव होता है.
यस.
ठीक है, क्लियर है. तो देखो मैं ऊपर बी से सी में जा रहा हूँ, मेरा डायरेक्शन ऊपर की तरफ है, करंट नीचे जा रहा है. तो जब करंट अपोजिट
हाँ
डायरेक्शन में जाता है तो वो प्लस होता है. प्लस होता है.
हाँ
क्लियर.
यस सर.
या
यस.
तो इसका डायग्राम बना लो और उसको लिख लो अच्छे से, वो भी इम्पोर्टेंट है.
हाँ सर जो वो पीछे के जो स्लाइड्स है वो दिखाओ ना एक बार.
हाँ पीछे की स्लाइड में दिखा सकते हो.
हाँ ये नहीं, वो फर्स्ट वाला फर्स्ट. हाँ एक मिनट. हाँ
इसको लिख सकते हो, इसको बोलते हैं जंक्शन रोल.